So welcome back to the class, students. Can you hear me properly? Am I audible?
Yes, sir.
Yes, sir.
Okay, so how are you doing? We are meeting after a long time.
Good, sir. How are you?
Yeah, I'm also fine, thank you. It has been quite a long time, but I think you have already uh, passed a very good time during your holidays, right?
Yes, sir.
How many days of holidays have you got this time?
5 days.
5 days. Okay, great. So are all the classes happening online still now, or it is happening on campus? Except my one.
Both, sir. They're going offline and online. For the students who are still at home, online classes are going, and for the students who are in campus, offline classes are going.
Okay. So okay. So when is your final exam?
Sir, according to the schedule they gave us, it starts on 13th of December, and if I'm not wrong, it ends on 18th, but we don't have a proper timetable for the exams.
So probably it is going to start at the middle of December, right?
Yeah.
Okay,
Yes.
great. So today we will actually continue our discussion on time value of money. Okay, can you help me to remember what was the last discussion? Anybody?
Sir, can you repeat the question?
So what was the last discussion in the last class? What have we done in the last class?
Sir, can you hear me?
Hmm?
Sir, can you hear me?
Yeah, I can hear you.
Sir, we have discussed about calculating the present value of multiple cash flows.
Have we done multiple cash flows?
Yes, sir. I mean, for present and future also we have done.
Okay, we have done single cash flow and also multiple cash flow, right?
Yes, sir.
We have discussed both theory and also a software application.
Yes, sir.
I remember. Yes. Okay. Today we will continue from here. We will continue from here actually. So let me take a while because I'm trying to open my notebook so that I can share that with you. So to remind you, we were discussing about giving you some kind of reward, giving you some kind of reward if for doing what, for completing the first case study or what. So for whatever reason, I was asking you that I will give you some reward. So I gave you two options. One is you will get the reward today, and another one after in future actually. So we have found that you are so clever that you want the reward today. You don't want to wait for a long time. So after the discussion about this thing, we have come up with the conclusion that the future amount of money is, the value of the future amount of money is less than the same amount of money at present. Do you remember that? I'm just trying to help you to remember, because if you don't remember that, it will be difficult for you to understand. So we have come up with the conclusion that the same amount of money, let's say $100 today and $100 after 1 year or 10 year, whatever in future, these two are not the same, right? Have we come up with that conclusion?
Yes, sir.
Okay. So So we have come up with that conclusion. And then we have given the example of different cash flow. And we have also said that, well, if this is the case, then how can we actually, how can we, how can we find a way of calculating the equivalence between the present value and future value of certain amount of money. So for example, what is the equivalent amount of today's $100 in future after 1 year, after 2 years? So we have come up with a concept of discount rate or interest rate or time preference rate or whatever we say, or a kind of rate that will help us to calculate the equivalent amount of today that is that has the same value as an amount in future. Okay, so we have got several inputs. One is the present value, another one is the future value, another one is the number of year, and the other one is the what? The discount rate or interest rate.
Excuse me,
Am I
sir.
right or wrong?
Excuse
Yes.
me, sir. Sir,
Yeah.
we can't see the screen, sir. Like a
No,
blank.
no, I have not started to share yet. I will share it after doing the recap.
Okay, sir.
So we have come up with these inputs. One is the present value, another one is the future value,
Yes, sir.
and the other one is the other one is what? Discount rate, present value, future value, number of year, and
Discount rate.
what? Discount rate. Yeah, this is what I'm saying. So then we have discussed about the possibility of calculating present value of a future amount. Then just my screen sharing is not working. Okay. So then we have actually given some examples of calculating the present value and future value of a single amount. Okay, present value and future value of a single amount. Then we have discussed about the present value and future value of multiple cash flows in happening different years, right? And we have also done that in Excel. Right or wrong? At least tell me yes or no.
Yes, sir.
Only one student. Okay, anyway.
Yes, sir.
So so today what we are going to do, today we are going to I'm going to show you another example so that you can remember, because it happened 15 days ago. So it will help you to remember, and then I will proceed to some special cases of multiple cash flow. Okay, special cases of multiple cash flow. For example, sometimes our multiple cash flows are equal. In year one, we have $100. In year two, we have again another $100. In year three, $100, and it will continue for 10 years. So what is happening in every year, we are having the same amount of cash flow. So that is it single cash flow or multiple cash flow? Is it single cash flow or multiple cash flow?
Single.
If we have cash flows in year one, we have $100. In year two, we have another 100. In year three, another 100, and it will continue for 10 years. So do we have single cash flow or more than one cash flow?
More than one.
More than one, right? More than one cash flows. So that is the point actually. That is also multiple cash flow, but we can use a very easy formula using net present value, sorry, using using the net present value, that will allow us to calculate the uh, future value or present value of the multiple cash flow having special criteria. Okay, so before that, let me tell you that we have a special name for this kind of cash flow. Let me share the screen now. Let me share the screen now. Can you see the Excel file?
Yes, sir.
Okay.
Yes, sir.
So now what we are saying, that let's say we have year 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 and 10. Okay, so these are the years. Okay, now we have cash flows. Like in year 1, like in let's say in year 4, we have a cash flow of $120. Cash flow, let me write dollar within bracket so that it is understandable that all are dollar. And also we have got some other information like the discount rate. The discount rate is equals to let's say 12%. You know what is discount rate, right? Discount rate is the rate at which we can actually exchange the present cash flow and future cash flow. We can actually calculate the equivalent amount of present amount that is corresponding to an amount of future cash flow, or equivalent amount of future cash flow corresponding to a certain amount of present cash flow. So that is the discount rate, and you already know how to use that. So let's say, let me give you the example of one single cash flow. So if you want to calculate the present value of this cash flow, in short, sometimes we write PV. Okay, so if you want to calculate the present value, then the present value will be equal to, do you remember what function we use? Anybody can help me to remember the function, name of the function?
NPV,
So
sir.
is equals to PV of
PV or NPV. Let us try. It is okay to make mistake when you use software application. If you make mistake, no problem, you can use the another alternative one. You can remember the right one. So if you use PV, then what will happen? You can see within bracket, we can see several inputs. One is the rate, another one is the number of period, NPER, and PMT is the regular cash flow that we don't have now, and FV is the future value. We actually have that. Type is, if you remember, either end of period or beginning of period. So by default, we consider end of period. Now, if by mistake, if you use NPV, by looking at the formula values, you will understand that whether it is usable or not. So in NPV function, you can see that within bracket, you have rate and different values. You don't have any number of period input, right? So, so you can see that we actually have to use which one, NPV or PV? Which one do we have to use? NPV or PV? You have to use PV. Okay, so try to do it by yourself in your computer. Okay, I will come back after 10 minutes. Okay, is that okay or not?
Yes,
Hello?
sir. Yes, sir.
Yes, sir.
So I have something to do for 10 minutes time. I'll come back. So by this time, try to do it in your computer so that you can remember the last class lesson. Okay, have you done it? Hello? Have you done it?
Yes, sir.
So please match it with what I'm doing. Okay, so the present value will be the rate. So if I click here, it will actually select the rate, but remember that in this case normally we will lock the cell. So in your Windows computer it should be F4, and in Mac function F4 or something like that. Or if you do not find it, you can just type $sign before C and before 1, or if you have another cell before the row heading and the column heading. And the number of period, how many years? You can see it is 4 years. So that is also fixed in this case because you are not going to change it. So this is also fixed. Then PMT is 0 because we do not have any regular payment in this case, but we have a future value, which is 120. And the type is, if it is end of period, then it is 0. Okay, so this is how you can actually calculate the present value. So present value is always at time 0. If you don't want the minus sign, you can put a minus before the function so that you get the value without any minus sign, because you can handle with the minus negative things by yourself. Okay. So this is how you can actually calculate the present value of a single amount. But if you have multiple, this is the present value of single cash flow. This is the present value of single cash flow. Present value of single cash flow. Present value of single cash flow. Now, if you want to calculate the present value of multiple cash flows, I'm just showing you very quickly so that it helps you to remember. Okay, just copying it below it. Multiple cash flow. So in that case, I will delete this one straight away because the function formula will be different. Okay. So let's say we have cash flows amounting 230 in year 1, 300 in year 2, 50 in year 3, 0 in year 4. In year 5, we have 210, 115, 511, then 982, 721, and in year 10 we have a cash flow of only $20. So if this is the case, so you can see that we have so many cash flows in different years. So what is the present value of this entire set of cash flow? We have already done that in the last class, but still we can sorry, still we can do that for for just review purpose. So how can we calculate the present value? We have to use the NPV function. Am I right or wrong? We have to use the NPV function because NPV function allows us to use the rate and also all the values. And if we take all the values, that by default indicates the number of year, because in every year you have a value. In year 4, you don't have any cash flow, but still you have a value of 0. Okay, so let us link the rate, which is cell C19, and then we just select all the values starting from year 1. Remember, you have to start from year 1. Okay, then we close the bracket and we get the present value. So this is the present value. Do you understand or not? Hello? Excuse me, do you understand or not?
Yes, sir. Yes, sir.
Do not be so miser in just saying yes or no. Be very generous. Just press your space bar and say yes sir, no sir, at least yes, no, at least I understand that I'm taking class of some living student. Anyway, so there is another way that we have shown in the last class. Very quickly I'm going to show, that is discount, using the discount factor. Discount factor. So how can we calculate the discount factor? It is actually by calculating, because we are calculating present value, we actually call it present value interest factor. Okay, present value interest factor. Present value interest factor. So that is actually 1 over 1 plus r to the power n. So we have done the theory already in the last class, so I'm not going to repeat that. So if I repeat everything, that it becomes the copy of the last class. Okay, so the present value interest factor is equals to 1 over what? 1 over 1 plus the discount rate. We have to fix that to the power what? To the power the number of year. Okay, do you get it? So I use another bracket. I feel comfortable with that because I want to keep all this together as a denominator. So I'm not locking cell A23 because when I copy down, it should also adjust. So this is how we can calculate the present value interest factor. We don't need here, so I can delete this one. And then what I can calculate is present value of cash flow. Each cash flow, I can calculate the present value of each cash flow here. So this one will be equal to the cash flow times the present value interest factor. And we can go down, Control D. So we have got the present value of each cash flow. We can reduce the decimal. 2 decimal point is sufficient, and then we can get the present value as a sum of all these things. Okay, so equals sum. Now you see that we have got the same result. We have got the same result. Are we getting the same result or not?
Yes, sir.
We're getting the same result. So but if you want to calculate the future value, then the result might be a bit different. If you want to calculate the future value, actually you cannot use this single function for that purpose. I'll show you that. Anybody has any question? Okay,
Sir,
I feel
you're on
that.
mute.
Yeah, no problem. So for all this thing, we can also calculate the future value. Let me copy the whole thing and then paste it here. Future value of single cash flow. So in that case, we will have future value so here the function will be FV. Am I right or wrong? And other things are the same. Rate, NPR, PMT, PV. Okay, now we got another problem. Look, future value in which year? Future value in which year? So to make the example correct, actually the example is not correct because this $120 is already in the future. So if we have this amount in year 0 and we want to calculate the future value in year 4, then we can do it. We can do it in this manner. So let's say we have future value, and now this is the rate. This is the number of period. Number of period is already 4. It is in cell number F4, so we have to correct it, not F4, F9. Okay, we have to correct it, F9. Now you see this one is highlighted, and we have 0 regular payment, and we have PV that is not in G9, that is in which cell? Can you tell me? G5. Okay, so we have to correct it, G5. Now you can see it is highlighting the correct cell. So if we enter, we get the future value of this $120 in year 4. Okay, future value in year 4. Okay, in year 4. Let me write it in bracket so you can understand. Okay, now the future value of multiple cash flows. Future value of multiple cash flows. So in that case, we want the future value in year 10. We want the future value of all these cash flows in year 10. How to calculate that? Let me delete this one. Let me delete all this thing. Actually, in this case, we cannot use the function something like NFV. We don't have that. So only way is to do in this manner. So in that case, we have to calculate the future value interest factor instead of present value interest factor. So how do you calculate the future value interest factor? Future value interest factor is simply 1 within bracket 1 plus the discount rate, which should be locked because you cannot change it, to the power number of years. Is it correct?
No, sir.
No, yeah. We want the future value in year 10 and it is in year 1. So we have to count how many years forward it will go. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we have to remember that. So ultimately the power will be equal to this one, which must be locked. No, Fn or control F4 or only F4, and it has to be within bracket minus this here, and you should not lock it. Okay, then you get the future value interest factor. We have already explained all this thing in the last class. So you have got the future value interest factor. Now we need to calculate the future value of cash of each individual cash flow. So the future value of the cash flow will be equal to this one times this one. Okay, now you have to copy it down. Okay, then get the sum of all this thing so that you get the future value of all these cash flows. So this is how you can calculate the future value of multiple cash flows. Okay, now let us come to the new type of cash flow. Okay, and I will show you how to do that. So now I'm changing the heading, future value of multiple equal cash flow. Okay, multiple equal cash flow. Sorry, present value. Okay, let us talk about the present value first. So present value of multiple equal cash flow. Let me hide it to avoid any confusion. Okay, we want to calculate the present value of multiple equal cash flows. So we are going to change the example. Let's say every year we are going to get $120 cash flow. Every year we will get how much? $120. Okay. Now there is no problem actually, you know, if you have cash flow of 120, 350, 0, 200, a different amount of cash flow versus if you have equal cash flow, the process will be the same. Am I right or wrong? Am I right or wrong?
Yes, sir.
Yeah, because just cash flow has changed, and you can see we can use either method to get the same value, 678.03, 678.03. Okay, this is how you can actually calculate the the present value of multiple equal cash flows. Do you understand or not? But why I am showing this? Because this is a special type of cash flow with a great significance. You will find this kind of cash flow with a great significance in future. Okay. Again, if you want to calculate the future value of multiple equal cash flow, you can use the same process. Let me unhide that one. Okay, and let me correct it. Future value of multiple equal cash flows. Equal. We should use the plural number. Well, so in this case, let's say we have the same cash flow every year again, and you can see the future value is 2105.85. Okay, got it? Got it or not?
Yes, sir.
Okay. Well, so this is how you can calculate the present value and future value of multiple equal cash flows. So why I am calling it, why I'm showing it with a special significance? Because in many cases, you will find that, for example, if you take a loan, sometimes the bank will ask you to repay the loan in equal installment. So in that case, you are having equal cash flow every year. So, and not only that, if you buy a bond from the bond market, then you will get the equal in coupon interest payment every year or every 6 months or every 4 months or every 3 months, whatever, so that is also an example of this kind of cash flow. So we have very practical significance of this type of cash flow. This is why I'm giving a special example. Okay, so let's say so actually there is a special name of this type of cash flow. We can say that it's actually an annuity. This is called an annuity. The multiple equal cash flows, when the cash flows occur every equal interval of time, like every year or every 6 months or every day or every month. So the time frame is equal, time difference is equal, and also the amount of cash flow is equal, and it has an ending point, then we call it an annuity. So you can see that here we have 120, 120, 120. Every year we have a certain amount of cash flow, and it is happening every year, and it is ending at a certain point of time. So we can call it an annuity. So for calling a cash flow annuity, you need 3 criteria. Number 1, the cash flows must be equal. Number 2, the cash flows must occur in equal interval of time. And number 3, the cash flows must end at some point of time. Okay, so if these 3 criteria are fulfilled, then we can call it annuity. So this is actually the present value of an annuity. Okay, similarly, if this is also an annuity. Okay, do you understand or not?
Yes, sir.
So in this case, actually, you are getting the cash flow at the end of the year. So if you get the cash flow at the beginning of the year, then we call it annuity due. So there are 2 types of annuities. There are 2 types of annuities. 2 types of annuities. What are the 2 types of annuities? One is ordinary annuity, and the one is annuity due. So what do we mean by annuity due? By annuity due, we mean cash flows will occur at the beginning of period. Okay, and what do we mean by ordinary annuity? The cash flows will occur at the end of period. End of period. Got it or not? So in this case, is it ordinary annuity or annuity due? Tell me whether it is ordinary annuity or annuity due.
Ordinary annuity.
Ordinary annuity, very good. Ordinary annuity, okay. And in this case, it is also an ordinary annuity. Normally, if nothing is said, we assume that it is ordinary annuity. This is why in the function, we are always using zero at the last here. Sorry. Where is that? No, we did not use that yet. Anyway, so let us give an example of present value and future value of annuity due. So in this case, I'll change the heading. I will call it annuity due. Okay, and again, this is annuity due. So what is the change in this case? The only change is the cash flows will occur at the beginning of period. That means the first cash flow will be in year 0 and the last one will not be there. So the whole cash flow will shift upward by 1 year. Now we have to correct the calculation. You see, this portion will go up. Okay. Now you get the present value, the correct present value of the of the annuity due. And we don't have any, we don't need any factor here, so we delete it. And also we need some adjustment here. We have to bring it by one upward. And not only that, we actually need the present value interest factor for the first cash flow as well, which will be 1. So this one be equal to, we don't need to type again. We can just copy the function. So let me check again if it is okay. B times C, correct? So if we don't need that because we don't have any cash flow here. So it will be sum of D62 to D71. Okay. So I don't know why we are getting different result. Maybe let me check if we have correct here. The NPV is C19. Where is C19? That is the red, right? Actually have to select this one, C59. Even if you do not use the dollar, it's okay here because you're not copying this formula, it's fine. And then the values are, oh, I see. From B62. Do you understand why we are having a different result here? Because Excel is assuming that the first 120 is in year 1. And that is the reason. Actually, you cannot use this formula in this case. You have to rely on this calculation. Very simple. You have to use this formula. But let me try PV. Rate is this one, and comma, number of period, how many years we have? 10, right or wrong? And then PMT is 120. We don't have to select all. Future value is 0. Type, beginning of period. Okay, that means it will be 1. Then you will get the right result. So in this case, you can use the PV function. Do you get it? Hello, students. Do you get it or not?
Second repeat.
Repeat. Okay. So you can use the PV function here. PV. The rate is this one. I'm not going to lock, because this formula, this function will not be copied anywhere. So not locking is okay. The number of period is 10. Although you can see the last amount is at the end of year 9. Actually, that is the beginning of year 10. We have said that the cash flows will occur at the beginning of the year. So beginning of, this is why this $120 is the cash flow of year 10. So you have total 10 years. Number of period is 10. Then PMT, that means every month how much, or every year how much, every period how much, 120. Then future value, we don't have any remaining future value. Then type, beginning or end, which one? Beginning of period. So you get 759.39. To get rid of the negative sign, let us put a negative sign before the function. This is how you can calculate the present value of annuity due. Okay? Okay or not?
Yes, sir.
Yes, sir.
Let us try the similar function for future value of annuity due. Yeah, it is possible. So the rate is here 12%. Number of period is 10. Before that, let us correct the structure of the cash flow. So there will be 120 in year 0, and the last one will be deleted, because the cash flows are happening at the beginning of year. And we also need to calculate, we also need these values in year 0, because and this one we don't need. Okay, and here it will be taken 1 year up. Now let us check if it is okay. 1 plus this one, sorry, 1 plus H19. Actually, that is okay because we are using the same rate. Still, let me correct it. It is actually H59. H59, 1 plus H59 to the power F32. So in this case, it is not F32, it is F72 minus F62. 10 minus 0, because it will proceed to 10 year. It's fine. Now we will copy this one. Actually, when you use a spreadsheet for doing any financial analysis, this is a very common practice that you copy from another place and adjust it accordingly, according to the current scenario. So now, if you have any question, whenever I'm doing, just do not keep quiet, and if you do not understand, ask me why it is so, or why it is not so, or something like that. So now we see that our future value is this one. Now let us use the direct form function. Future value, rate is here, comma, number of period is 10, comma, PMT is 120, comma, PV is 0. We don't have any special PV. Then this is the beginning of period value. So 1. You get the same value. Do you understand? Have you understood or not?
Yes, sir.
Any question? So we have understood how to calculate the present value and future value of annuity due. That means when the cash flows are occurring at the beginning of year. Okay, let us go back here and see. Let us use the similar function. I'm going to insert another row. For annuity, ordinary annuity, we also can use the function like this one. PV, simple PV and simple FV function. So present value again equals PV. That this is the case of end of period. So the rate is here, comma, number of period is 10, comma, future value is 0. That means we don't have any extra future value. Okay, then we have type is 0 because we are considering end of period. What happened? Let me do it again. What is the rate? Rate is 12%. The number of period is 10. Then PMT is 120. Future value is 0. Type is end of period, that is 0. Okay, you got that. You got that. Okay, so future value can also be calculated in this manner. Equals. The only difference is instead of beginning of period, you are using end of period. That means in the last part of the function, instead of 1, you are using 0 here. All the things are the same. Number of period 10. PMT, that means equal payment every year, is 120. PV is 0 and type is 0. Okay, you get the same value. So you have understood probably how to calculate the present value and future value of any ordinary annuity and annuity due. Now we are going to calculate we are going to learn about another type of cash flow, which is called perpetuity. So what is a perpetuity? Perpetuity is a special type of annuity that never ends. Remember, we have said that in case of annuity, it will end somewhere. I have said the 3 criteria to call a multiple cash flow annuity. One is equal amount, another one is equal interval of time, and the third one is it will stop somewhere. But if the annuity does not stop, it continues forever, then we call it a perpetuity. We call it a perpetuity. So in case of perpetuity, what will happen? In case of perpetuity, the cash flow will continue to happen. Continue to happen. It will never end. It will continue to happen forever. Forever. It will never stop. So this kind of cash flow is called perpetuity. So perpetuity does not have any end point, so we cannot really calculate the future value of a perpetuity. We cannot calculate a future value of a perpetuity. So I'm deleting this one. So what we will do, we will only calculate the present value of multiple equal cash flows that never ends. That never ends or continues for, let us be positive, that continues forever. That means the perpetuity. Perpetuity. Okay. So in this case, actually, you do not need that structure of year, because we just need to say how what is what, what cash flow we have, how many years of sorry, no year, because it will be forever. So what is the equal cash flow? Per year. Let's say it is 120, and nothing else. You don't need anything more. So the present value of perpetuity. It's very simple formula, actually. Will be equal to equal cash flow divided by the discount rate. 1000. Okay, so this is a very special formula. When the perpetuity, when the cash flow never ends, just the equal cash flow divided by the discount rate. That's all, nothing else. Clear to you or not? Students, are you clear or not? Any question? Okay, if you don't have any question, now I will ask you to practice.
Sir, a
by
doubt, sir.
Yeah, please.
A doubt. Sir, I mean, we can't use the perpetuity for unequal cash flow, right?
Sorry, again.
Perpetuity for unequal cash flows.
Perpetuity.
Yes, sir. For unequal cash
Perpetuity is
flows.
always equal cash flow. If the cash flow is
Okay, sir.
unequal, that is never perpetuity.
Okay, sir. Thank you, sir.
So everyone, please practice these things, and I'm going to ask you to show. You don't have to practice everything for now. For now, practice calculating this one. Present value of this part. Okay, present value of multiple equal cash flow annuity due. Practice this one, and I will ask you to come forward and show your calculation. Just this one, okay? If you can practice this one, then that will be sufficient for now. So are you going to practice it now?
Yeah.
Okay.
Yes, sir.
Yes, sir.
Okay, please do, for your good. For it is not for me, it is for you, actually. So do the practice, and then I will randomly ask you to show it in your computer by sharing your screen. You can always escape by saying that my computer is not ready and so and so. I won't mind, but I'm sure that there are many students. In fact, most of you are eager to learn. So if I invite you to show your demonstration, you will happily come forward. Okay. So how much time do you need? I think 5 minutes will be okay. Do you need 5 minutes or 10 minutes for practicing this?
10 minutes.
Okay, I'm giving you 10 minutes from now. Okay, are you done? So any volunteer who wants to come forward and show it to the students, to the class? If I do not find any volunteer, I will have to call randomly. Anyone wants to show the calculation of present value of multiple, present value of annuity due actually? Can you hear me?
Yes, sir.
Yeah. Anybody wants to show it? Okay. So let me call the name randomly. So Mansi Kaushik, are you there? Mansi Kaushik. Not responding. Rohit Elitam. Rohit Elitam. Not responding. Duti Mala. Not responding. Khushi Rawal. Lahari. Not responding. Ullash
Sir,
Mehta. Yeah.
yes,
Yeah, Lahari, can you demonstrate the calculation of present value of ordinary annuity?
sure. Actually, I didn't know much about
Okay, I
this.
understand. Then Jivan Sai. Gaddam Shashank. Govind Maheshwari. Anika Raj.
Yes, sir.
Are you interested to
Share my-
demonstrate it?
I'll share my screen.
Yeah, please. At last I got someone. Thank you, Anika.
Sir, it shows that the host disabled participant. Sir, can you enable participants?
Yeah, I have given the sharing permission. Please do.
Sir, she got disconnected. She's
Uh,
joining.
yeah, she is sharing the screen. Okay, let us give her time. Okay, I think she has got disconnected. So Yashwant Tati. Anika Raz, are you back?
Sir, I think I got.
Yeah.
Okay,
Okay.
I'll
Take it. Yeah.
share it again. So you can see my screen, right?
Yeah, I can see, but what I would like you to do, probably you can delete, the PVIF, and don't worry if you make mistake, don't worry, we will help you. That is not a problem. So delete from the PVIF and PVCF, delete all this. Oh, you are doing it again here.
Yeah, I'm doing it this
Oh,
side.
okay, you can do that, no problem. Okay, at first, let me correct you one thing. Actually, in this annuity, you don't have any cash flow in year 10. The $120 of year 10 will be in year 9.
Yes.
So you have to delete this one. Yeah, I forgot to last one. Delete the last one. Not that. Yeah, yeah, right. Okay.
Yes, sir, done. Done, sir.
Okay, great. But I also want to see how we can calculate the present value using the PV function. The same formula. Have you shown that? Okay, can you go to that cell so that we can see the function?
Sorry, sir, I couldn't get you.
Yeah, click that one. Click that one. Click cell G22. Yeah. Right. Okay. Okay. Thank you very much. Thank you very much. Well, so we have already done up to this. Now, I also want another thing to teach you. That is the present value of multiple equal cash flows that continue forever, and there is another characteristic: continue forever and grows at a constant rate. It is called growing perpetuity. So how is that? Actually, in that case, what will happen? Let me show you year by year. 1, 2, 3, 4, 5, 6, 7, 8, 7. And it will continue forever. So I'm not writing all this thing. And the cash flows are something like this. If the cash flow of year 1 is 100, then in year 2, it will grow at a constant rate. Let's say the growth rate is, let's say the growth rate is, let's say 2%. 2%. Okay, discount rate is there. This is the next year cash flow. the next cash flow. Next cash flow is 100. And we want to calculate the, let me delete this one because we'll write that at the bottom. Okay. So how is that cash flow actually? The next cash flow is 100. So the second next, that means the cash flow after that one will not be equal to 100. And not if it were a perpetuity, then every year the cash flow could be 100. But because this is a growing perpetuity, the next year cash flow will be equal to this 100 times 1 plus the growth rate. 1 plus the growth rate. Okay, 1 plus the growth rate. And the next year it will be again equal to the previous year cash flow times 1 plus the growth rate. Yeah, 1 plus the growth rate. So this is how the cash flow will be increasing every year, forever, every year, forever. The cash flow will be increasing every year, forever. The cash flow will be increasing every year, forever. So this is the type of cash flow. And this is the type of cash flow of a growing perpetuity. Okay. Now, if we want to calculate the present value, we have a very simple formula that we can use. Let me write it here. PV of the growing perpetuity. So it will be equals to the next cash flow divided by discount rate minus the growth rate. Okay, you get the present value. Okay, so the growing perpetuity is how you have to understand how the growing perpetuity is different from perpetuity. In case of perpetuity, same cash flow occurs every year forever. But in case of growing perpetuity, the cash flow increases at a constant rate. This 2% will never change. Okay. And the next year cash flow is also fixed. So it will continue forever. The growth will continue forever. The cash flow will also continue forever and it will never stop. And you also need to know the difference between perpetuity and annuity. Perpetuity, and the only difference is annuity stops somewhere after a certain number of years, but perpetuity never stops. And how the growing perpetuity is different from perpetuity again? In case of perpetuity, the same cash flow will happen every year, but in case of growing perpetuity, the cash flow will grow at a constant rate. Okay, constant growth rate. So this is called growing perpetuity. Okay. Now, I want to discuss about a very practical application of these time value of money concepts. Let's say we do not really like the online class. So what we are going to do, we are going to build a dream classroom, maybe somewhere in India, where I can be teleported there, during at the beginning of the class, and after the class I can also teleport back to my country, and all the students can also be teleported there. So give me a name of a very nice place where we can build a dream classroom. Do you know India, or you don't know any place of India, any nice place of India?
Sir, Kamkol, sir.
Spelling.
KAM
KAM
KOLE.
Kamkole. This is a very nice place, right? Is it a nice place? Hmm?
Yes, sir, it's Oxon. Oxon University is there.
Oh, Oxford University is here. So you want your campus there?
Yes, sir.
Okay. Come call. Well, we can see that. Do you recognize this place? Hmm? Can you see the picture?
Yes, sir.
Do you recognize this place?
No, sir.
No, but I've just got the photo of this place from internet within Kamkol. Empty space, so we can build a classroom here. Because it seems to be a very empty space if there is no other problem. So we can go there and see, right? So let's say if we want to build a new classroom for our class here, how much it will be, how much will it cost? Just idea, maybe 2-storied classroom. The ground floor will be for teleport system and the first floor will be for our class. So how much will it cost? For this class, for building this classroom? Any idea?
100 crores. 100 crores, sir.
100 crore only for this 2-storied building. It's not going to be very big actually. No? Are you sure 100 crore will be needed for building that classroom?
Sir, teleportation, right? So we need new technology, everything.
Okay, let's say we have the teleportation system already. Classroom like this. Like this, okay? So how much will be the cost, the construction cost, other than the teleportation system?
50 lakhs, sir.
50 lakhs. Okay, is it 50 lakhs? Sorry about the noise. Oh, someone also suggested Himalayas. Anyway, because you did not tell me anything, this is in the chat box. So anyway, we have already chosen. Okay, so as one of you have said that it will cost 50 lakhs to build this classroom. Do we have 50 lakhs? Do you have money? We don't have. So let's say still we are so eager to learn in this classroom that every one of us are giving 50,000 rupee per head. So if we have 50 active students in this class, we will get 25 lakhs from our pocket. And when we already build the foundation and many other things, the bank is interested to give us the remaining 25 lakhs of loan. Is it possible or not? The bank is
Yes,
now
sir.
interested to give 25 lakhs of loan. Okay, that can be possible, right? So loan for the construction in some coal, right? We're thinking about a loan from the bank for construction. So what is the loan amount? The loan amount is 25 lakhs. Loan amount is 25 lakhs. Now, whenever the bank is, probably the bank is going to give the loan, you also should know the rate of interest the bank is going to charge. Okay, the rate of interest on the loan. So what is the loan interest rate in India normally? Normally, what is the interest rate of loan in India? Are you going to help me?
Sir, it is 9 to 10%, sir.
Yes, I can see that on the screen actually. I can see that in the internet. I was searching what is the usual interest rate. You can see here. Different bank has different interest rate. So this is from bankbudget.com, whatever. I have just randomly chosen a source. So it says that the interest rate is sometimes it is also very high, as high as 26%. I don't know why. IDFC First Bank. So what's specialty with that bank? Even we have 31.5% from IndusInd Bank. Do you have that bank in India?
Yes, sir.
So why are they charging so high rate of interest? Why people are agreeing with that interest rate? IIFL 24%. Oh my God. Anyway, so let us use a normal, something that is acceptable to everyone. 12%. Okay, 12%. Let's say some bank has agreed to give us a loan at 12% interest rate. And how will normally we'll get the loan right now once it is sanctioned by the bank. Once the bank approve the loan, we will be able to withdraw the loan. Now the thing is, how will we repay the loan? Normally, how can we repay the loan? Normally, loans are repaid in installment. So let's say we will repay the money after getting our job. So let's say you are going to get a job right now. So you will repay the loan in installment because you will get monthly salary, and from the salary, every one of you will repay the loan every month. Okay. Forget about every month. Let's say that you will repay it every year. Okay, let us use the easier one. Later on, we'll go to the monthly installment. So you will repay the loan in yearly installment or annual installment, yearly equal installment. Okay, we don't know how much is the yearly equal installment. So that is a question. And another thing is, you will repay the loan for how many years? That means the loan is for how many years? The maturity of the loan. Maturity of the loan means the number of years for which you are taking the loan, or the number of years that you will take to repay the loan. So let's say we will take about 20 years to repay the loan, so that our installment is not that high. 20 years. Maturity of the loan is 20 years. Are you understanding or not?
Yes, sir.
Okay. Now the question is, what will be the installment? Can you tell me how much will be the installment every year? If you cannot tell me, just tell me, no, sir, I cannot tell you.
Sir, will it be 1,25,000?
Divided by 20.
Yes, sir.
Yeah, that is a very good try. Thank you very much. But you should remember that you also need to pay the interest. Okay, so the thing is not that much easy actually, you know. So let us write down because we have 20 years. So let us write down. But thank you for your answer, because nobody is generous to give me any answer, and you have come forward and saved me. Thank you very much. This class is so, I feel so, what should I say? Everyone should be pity for me. So actually we are taking the loan right now. So let me also put one cell here to say year 0. So in year 0, we're getting $25 million. This is why it is plus. And then we are going to repay. This is the loan. Okay. And the installment, we don't know how much. Let's say it is called PMT, payment, equal payment. This is why all are the same, not PMT1, PMT2, rather all are PMT. Why? Because the installments are equal. The installments are equal. Now we have to find what is the equal amount we have to pay every year. Now let me tell you, forgetting about this one, let us delete this one. If we forget about the loan amount, if we only consider our installment payment, is it an annuity?
Yes, sir.
It is an annuity. Why? Because we are getting equal cash flow, so many equal cash flows, okay? And we are getting those equal cash flows every year, equal interval of time, and it will be at the end of year 20. So all the 3 criteria are fulfilled. Therefore, it is an annuity. Okay, just like what we have shown here. Just like here, this 120 is PMT there. Okay, we don't know what is the amount here. Okay, but we know what is the current loan amount. What is the current loan amount? The current loan amount is 25 lakhs. This is actually this must be the present value of all these PMT, all these equal amount at 12% rate. This is why the bank has agreed to give us the 25 lakhs, because 25 lakhs is the present value. Let's say if you claim that no, the present value is 30 lakhs, and the bank is giving 25 lakhs, then definitely we will go to the bank and claim, well, give us the remaining 5 lakh, because the present value of what we will give in the next 20 years is 30 lakhs. Do you understand that? If the banks, if the present value of all those payment in the next 20 years is 30 lakhs, then definitely we are not going to accept 25 lakh. We will ask the bank to give us 30 lakhs because the present value is 30 lakhs. Why are you giving me less? Similarly, if we claim 30 lakhs from the bank or 35 lakhs from the bank will not agree. The bank will say, well, whatever amount you are going to pay to us in the next 20 installments has a present value of 25 lakhs. So why I would give you 35 lakhs? I will not give you 35 lakhs. So actually, this 25 lakh is the present value of that annuity. Have you got the point? Have you got the point?
Yes, sir.
Yes.
Okay. So now the thing is, we have learned how to calculate the present value of annuity if we know the PMT. PMT means equal payment every period. So previously we have done that. If we know that every period we are going to pay one, then what is the present value? We know. But now we have this present value and we don't know the PMT. Okay, so that is very easy to calculate. You can use the PMT function in Excel. There is a ready function for that, PMT. So PMT, you can calculate the PMT in this manner. PMT within bracket, then you have to select the rate, comma, the number of period is there, 20 periods. Present value is here, the present value, no future value, and type is it end of period or beginning of period? If I find a generous student to say yes or no.
End of the year.
Yeah, end of period. Thank you very much. May God bless you. So the yearly installment will be 3,34,696.95 or rupees. Okay, let me ignore the currency and all this thing. This is the yearly equal installment. Now let us try to check, if this is correct. If we really get this present value by putting those that as PMT. So let me copy it and paste value. This is just testing. Okay, this is not a requirement. We are just testing whether it is correct or not. So paste special, paste values. So we have got the values here. So this is now an annuity. Now let us calculate the present value at 12%. Okay, present value at 12%. So in that case, we'll be able to understand whether we really get 25 lakhs or not. So present value, the rate is 12%, comma, number of period, how many years? 20. PMT is this one. Future value is 0 and type is 0. How much do you get? Cannot 25 lakhs. Do you get it?
Yes, sir.
So it is correct. Our way of doing all these things is correct. So I'm deleting these things. Okay. So our yearly installment will be how much? 3,34,696.95. Okay. Now, this is not the end of the story. We want to know more. What else do we want to know? We want to know from the every installment, how much is the interest payment and how much is the payment of the main amount, main loan amount. For knowing that, we have to create a table. We have to create a table. Here, let me do it this side. Here, 1, 2, 3. Up to 20 years. Then beginning balance. So what is the beginning balance of year 1? What is the beginning balance of loan in year 1? We have taken the loan of 25 lakhs at the beginning of year 1. And so what is the beginning balance of the loan? Hello, sir.
25 lakhs.
25 lakhs. So equal this one. And we have to lock it because we cannot change it actually. Even if we do not lock, okay, because we are not going to copy this down. Okay, 25 lakhs. And then what is the installment amount? That is equal to this one. We have already calculated and we are going to lock it. Because the installment will be the same for every year. Now we have to calculate the interest due for the first year. So after using the 25 lakh rupees for 1 year, at the end of the year, how much interest you are supposed to pay? That is the beginning balance times the rate of interest. Am I right or wrong? The beginning balance at the beginning of the year, you have taken 25 lakhs rupees, and you are giving 12% interest. So at the end of the year, how much interest is due? 12% times 25 lakhs, because you have used 25 lakhs for the whole year as a loan. Okay, so that is the amount of interest payment. So interest payment is how much? 3 lakhs for 1 year. Do you understand or not?
Yes, sir.
Yes, sir.
Now, so out of the 3,34,696 installment, the interest payment is 3 lakh. So what about the remaining 34,696.95? What is that? That is the repayment of the original loan amount. Okay, so this is why we are calling it principal repayment, principal amount, principal repayment. So principal repayment is equals to the installment amount minus the interest amount. So this is the amount of the original loan amount that you are repaying. Okay, now ending balance. So at the end of the year, what is the remaining balance of the loan? Because you have taken 25 lakhs, and at the end of the year 1, after counting for interest payment, you have also repaid the actual loan balance by 34,000. So 25 lakh minus 34,000, sorry, 25 lakh minus 34,000, that is the ending balance of the loan when the first year ends. Okay, 24,65,303.05. And because that is the ending balance of year 1, that is also the beginning balance of year 2. That is also the beginning balance of year 2. Do you get it or not? Do you get it?
Yes, sir.
The December 31st, 11:59 p.m. balance is equal to January 1, 12 a.m. balance. This is what I'm claiming. So now other things are similarly calculated. So we can copy it down. And now we are not copying from the top because the sum of the elements of the top are coming from here. Okay, so we are copying from the second one. If you copy it down, you will see that the ending balance of the last year, 20th year, will be 0. The loan is fully repaid. So when it is 0, you can be sure that your calculations are correct. Okay, so this is called loan amortization schedule. This is called loan amortization schedule. This is called loan amortization schedule. Have you understood? Have you understood or not?
Yes, sir.
So let's say, I know that beauty is here, let's say later. If the rate of interest is 6% only, then what happens? If we just change the interest rate, then everything will be automatically changed. For example, you will the yearly installment will change and the whole amortization schedule will be updated. Can you see that? Can you see that or not? If the rate of interest is 10%, everything will be updated accordingly. If the rate of interest is 30% like that bank, everything is updated accordingly. Okay, we don't have to calculate it again and again. So this is a very important element, important component of this class. And you have already done case study and you have also submitted that. Now your next case study will be on time value of money. On time value of money. Well, so for now, what I will ask you, so that in the case study you have quite a good amount of marks. How many marks? Is it 20 or 30? Do you remember?
20, I think so.
20, yeah. Let me check it. This is the course outline. You can see that we have actually the first case solution and presentation has been done. That was on financial statement analysis. Now the next one will be on time value of money. Okay, the one that we are learning now. So your practice is very important. And most important is during class practice. When I ask you that I'm giving you 10 minutes time, do this practice right now, because you have just freshly learned it. So this practice is very important. If you do that, then after the class, your practice will be even more effective. You will be able to remember it for a longer period of time. Your skill will be developed. So it will not only give you the marks during the case study, it will also give you return during your career. During your career, that will also help you. That will also help you to be confident and to solve even more difficult problem. Okay. So if I ask you to do it during the class, and also if I ask you to demonstrate by sharing your screen during the class, please come forward for your good, for your betterment. It will not help me, it will help you actually. So probably very soon I'm going to assign you the case study, and this time I'm not going to extend your deadline for sure. Okay. So the case study will be assigned very soon. And now what I will ask you, I will give you 10 minutes time again to practice it, and I will ask the students to come forward and demonstrate, this loan amortization schedule given these amounts. Okay, practice it and come. I will come back after 10 minutes to ask some randomly selected students to show the loan amortization schedule. Okay, is 10 minutes okay for you?
Yes, sir.
Yeah, please carry on. Okay, are you done? Are you done with the practice? Anybody has done the practice? Come on. Can you hear me, students?
Yes, sir.
Have you done the practice? No.
Yes, sir.
Have you done the practice or not?
Yes, sir.
Okay.
Sir, can you
So-
share 1 second the screen share, sir? I got it out.
You want to show?
No, sir. I'm asking you to share the screen once. I got it out.
Okay. Yes. Yeah, what is your question? Yeah, Pradeep, what is your question?
Just I'm saying, sir. I mean, like, got it out, like how to do the table. Like, I got some different values.
So have you used the interest rate 10% or 12%?
12%, sir.
So let me change it to 12%. Now does it match?
Yes.
So that's the trick. Anything else? Anything else?
Just give me a second, sir. Sir,
Yes.
so for second year, the interest payment is calculated on the beginning balance, right?
The interest payment is calculated. Yeah, interest payment will always be calculated on the beginning balance of that year. Because you see, in the second year, we are actually using how much loan? Not 25 lakh, because we have already repaid 34,000 out of the 25 lakh. So we are using 24 lakh 65,303 in the second year. So definitely we are not going to give interest on 25 lakh. We are going to give interest on the amount we are using in second year. That is 24 lakh 65,303.
Yes, sir.
Okay.
Thank you. Thank you, sir.
Okay. Now, anybody who wants to volunteer and come forward to show the loan amortization schedule? Okay, nobody. So let me call one by one. Hemant Jadab. Varush Alladi. Not responding. Prabhams Reddy. Not responding. Rishitha Krishna. Not responding. Gaddam Shashank. Shandeep. Ritik Reddy. Santosh Reddy. Dutimala. Amulya. Ravali. Govind. Deepika. Sriharshi. Vadrinath. Vinila. Saiteza. Kevin. Karthik. Khushi. Yamini. Ojasvi Harshwal. Roshender Kisari. Ashrit Mudda. Jivan Sai, Rohit Elitam, Sri Shai, Sujit Mubha, Manshi Kaushik. None of you are responding. Krishna Chaitanya, Rishitha Marashani, Ullash Mente, Chetan Aditya, Yashwat Verma, Lahari Deepika, Rohit Srivasham, Akshara Jagar Lamudi.
Yes, sir. Sir,
Okay.
my Excel isn't working, sir. I'm on my iPad.
Okay, at least you have responded using your voice. Thank you very much. God bless you. Omar Kayamkini.
Yes, sir.
Okay, so can you share your screen and show the calculation? If you make any mistake, we will help you.
Sir, very sorry.
It's
I
okay.
logged into my mobile, sir. Next time I'll show, sir.
Okay, Laharika.
Yes, sir.
Can you do that?
Sir, my Wi-Fi is fluctuating, sir. I'm disconnecting and connecting, so I'll try to do it in next class.
Okay, Lahari Deepika. Mansi Kaushik. Krishna Chaitanya. Jivan Sai. Karthik Potharaju. Okay, I feel that okay, actually none of you are actually interested and also having some problem. Anyway, do it yourself at home. The class is over today. Thank you very much. See you in the next class.